So hi everyone, welcome back in another video of finding slope and deflection using Macaulay's method. Okay, so as I promised in my earlier video of understanding Macaulay's method over double integration method, so here I am with this new video. There we will be dealing basically with two questions, right? So the first question at your screen is basically you are given with simply supported beam. There are 2 point loads acting at B and one is acting at C. The point load acting at B is of 300 Newton and at C it is of 600 Newton. So the first step to calculate proceed is to find out the reactions, like what are the reactions at end A, what are the reaction at support A, and what are the reaction at support D. So we have named them as R1 and R2. As you guys already know that this is basically the procedure of finding out the reactions. How we are going to calculate the reactions. You can see there I have already write it down that let's say at support A, R1 is the reaction acting in upward direction and R2 is the reaction force acting in upward direction at support D. So R1 plus R2 are the upward forces, whereas 300 and 600 Newton forces, point load basically, are acting down in the downward direction. So R1 plus R2 is equals to 900. What is this? We have used equilibrium equation, that is summation of Fy is equals to 0. You already know this, right? Summation of Fy is equals to 0. Guys, this is basically equilibrium condition. This is basically equilibrium equation, right? So we have got one equation, but as you already know that we have two unknowns, so we require two equations, right? So another equation we are going to form with let's take moment about any hinge or at any support is 0, like as I have chosen the point A, moment at A becomes 0. So if moment at point A becomes 0, so R1 doesn't produce any moment, you already know. So 300 will produce moment but in clockwise direction. 300 into 1 clockwise moment there hai, so we have already write it down, and another moment will be given by 600 Newton into 2 plus 1 3, 2 plus 1 3, 600 into 3, that is again clockwise direction. I have already written this 600 into 3. But what does this R2 is giving us? R2 is giving us anti-clockwise moment. We have already write it down in the right hand side, right? These are these are clockwise moments and this is anti-clockwise moment. R2 into 4. Why 4? Because R2 is acting at distance 4. R2 is acting at a distance 4 from the left support. So in this manner you will be able to calculate the value of R2, that is 525 Newton, and once you get the value of R2 you can put this value of R2 in the first equation. From there you will get R1 as well, that is 375 Newton. So I have write it down all the values of the reactions, right? So as you are already aware that what I said that to write Macaulay's to use Macaulay's method, you need to first write down the bending moment equation in the very last section of the beam. As you can already see there, I have cut down the section in CD region so that I can cover A, B, B, C, all the regions all together itself, right? So I have taken a section in CD region at distance X. So now I'm going to write the bending moment equation at this region. Okay guys, so I am going to use this equation EI y double dash is equals to M. What is M? M is the bending moment, right? So EI y double dash, what is M? M is the bending moment. I am going to write the bending moment for this section that I have cut it down at X distance from left support. So as you can already see that R1 is producing sagging bending moment, R1 into X, that I have already written 375 into X. Then 300 okay, this 300 Newton is giving us hogging bending moment. It is acting at what distance? It is acting at X minus 1, yani ki this much distance. It is acting at basically it is acting at this much distance only. So I have already write it down, 300 into x minus 1 with negative sign. Why negative? Because it is giving us hogging bending moment. Then similarly 600 is acting at x minus 3 location, and if I talk about the nature, what is the nature? It is giving us hogging or sagging. Definitely it is giving us hogging nature, right? Okay, so let's move ahead. I have simply integrate this equation. I have simply integrate this whole equation. EIY double dash, say after integration it will become EIY dash, and if I integrate this, it will become 375 x square by 2 minus 300 x minus 1 square by 2 minus 600 x minus 3 by 2, and definitely one integration constant will also be introduced. Okay, now I'm again going to introduce this whole equation. This you can see below. EIY will become 375 x cube by 6 minus 300 x minus 1 cube by 6 minus 600 x minus 3 by 3 6, and of course if we integrate a, it will become ax, and new integration constant will also get introduced as b. Okay, now great. Okay guys, now what we are going to do is, now we are going to use boundary condition. Like what are the boundary conditions here? As you can already see in the beam itself, if I'll take x at 0, there will be no deflection. Why there will be no deflection at a region? Because at point a already support is present, and definitely if there is support, then support won't go downside na. So the first boundary condition will become, when x becomes 0, there will be no deflection at a, yani ki deflection at a becomes 0. And if I'll take x is equals to 2 1 and plus 2 plus 1 plus 1, it will become 4. That is, if x becomes 4, then deflection at d point will also be 0. Okay, hope you are clear with these two boundary equations that I'm going to use. Definitely guys, I have two unknown values, so I have to I need to know two boundary condition that I already know. That is, at x is equals to 0, I can show you below. This is written over there. At x is equals to 0, deflection y equal to 0. And if I use this boundary condition, or absolutely in this equation, you will get b is equals to 0. So first unknown quantity we have already know. This is the another boundary condition. At x is equals to 4, at x is equals to 4, y is again 0. Why y is again 0? You can already see there. At x is equals to 4, deflection at point D will also be 0. Why 0? Because there is a support. Okay, so there can't be any deflection where there is a support present. Okay, so if I put these values in this equation, using this boundary condition in this equation, it will simply give us the value of a. And as I have calculated already, you can see this, a is equal to minus 637.5. Okay guys, I request you, प्लीज़ एक बार आप लोग सॉल्यूशन को गो थ्रू कीजिए मेरे थ्रू, एंड आफ्टर दैट प्लीज़ सॉल्व दिस क्वेश्चन ऑन योर ओन एज वेल, बिकॉज until and unless you are not capable of solving these questions on your own, you won't be able to get any confidence in these type of questions. And trust me, they are just like a cakewalk. So please listen each and everything very carefully. If you have any doubt, please feel free to ask. Okay, so let's move ahead. Now what I'm going to do is, I'll simply use my values of a and b in the in above equation, like EIY equation. You can see I will substitute the values of a and b in this equation and in upper equation as well. So as you can see, EIY dash will become 187.5 x square minus 150 x minus 1 whole square minus 300 x minus 3 ka whole square minus this value of a. You can see there, this constant I have substituted by minus 637.5. Okay, now similarly in the same manner I am going to substitute the values of a and b in this equation as well. So EIY will become 625 x cube minus 50 x minus whole cube minus 100 x minus 3 square minus value of a I have substituted, that is 637.5 into x plus b is 0 already, right? So I have not written. Now Guys, this is the general equation that you are getting from using Macaulay's method. Now this general equation will help you to get slope and deflection at any point and at any point in the beam itself, right? आप beam में कोई भी point choose करो, at any random point you are able to choose any random point and you will get, definitely you will get slope and deflection, all the things. To get slope you have to use this equation, this whole equation, and to get deflection you have to use this equation. Okay, let's check. Okay, let's take any random value of x and let's check it once. Okay, if I'll take x as 0, let's take x as 0. You already know at x is equals to 0 deflection should be 0. Okay, so एक बार हम check कर लेते हैं whether we have whether the equations that we have formulated are actually correct or not, right? So if I'm going to check one of my boundary condition, that is at x is equal to 0 deflection should be 0. So I'm going to check whether it is actually 0 or not. So put x is equals to 0. Guys, you can already see 625 into 0 is already 0, and definitely please have a careful look there. Guys, I have already stated you while explaining Macaulay's method, while explaining the rules of the Macaulay's method, that whenever the term starts becoming negative, please neglect those terms. Like if I'll put 0 there, 0 minus 1, definitely it will become negative term, so I'll have to drop this term or I'll have to neglect this term, right? And if I'll put 0 there, 0 minus 3 is again becoming negative. Guys, please don't think that this square will make it positive. No, not at all. You just have to see the x minus 3 term or x minus 1 wali term. If it is becoming negative, then please simply drop the terms. So if I put 0 minus 3, it will again become negative, so I have to drop these two terms. So I'll simply drop these two terms. And if you put 625 into x equal to 0, and in this equation in this term as well, 637.5 into 0, you can clearly see that y will become 0. Okay, so yeah, definitely these equations are very much authentic and very much capable to give us slope and deflection at any chosen point. Okay, at any random point. Okay, great. So guys, as you can see, I have chosen a random point at x is equal to 0 to find out the slope. That means if I have to calculate the slope, I'll have to choose this equation. Okay, I'll have to choose this equation. In the earlier case I calculated deflection, so that's why I used this equation. But now I want to calculate slope at x is equal to 0, so obviously I have to use this equation. So use this equation, please. Put x is equals to 0 and definitely neglect those terms where your term becomes negative. Okay, so 187.5 into 0, it will become 0 only. Okay, so use this 0 minus 1 again, guys, it will become negative, so please drop this term. Okay, 0 minus 3 again negative, drop this term. So I'll have to drop these two terms. So what I'll be remaining with, I'll be remaining with 187.5 x square minus 637.5. Now put x is equal to 0. If I'll put x is equals to 0, I'll get this whole term as 0. I'll be remaining with minus 637.5 only, and minus 637.5. But you want to get deflection, but you want to get slope na. So you have to divide this term with EI. So that's what I actually did there. So minus 637.5, and EI ki value we have already given in the question itself. As you can see, EI is equals to 4800 kilonewton meter square. Guys, please be very much careful about the units. Okay, so I have converted kilonewton meter square into newton meter square. That's why I multiplied with the 1000. Okay, so if you calculate this whole value, you will get negative minus 0.1328 into 10 to the power minus 3 radian. Definitely, guys, what does this negative signifies to us? this negative simply tell us that the slope you will get will be in clockwise sense. What it is showing us that the slope you are going to get there will be in clockwise sense. You already know this sign convention, hope so. If you will have a positive slope, that means it is in the anti-clockwise direction, but if you are getting any negative slope, that means it is in clockwise sense. Okay, great. So guys, also I have also calculated deflection at x is equals to 1. I have again taken any random point, any random value of x to calculate, of course, deflection. So guys, what about deflection now? To calculate deflection, I'll have to use this equation. Of course, I'll have to use this equation. Now where I want to calculate at x equal to 1. So I'll just recommend, please try to put the values of x and check. First of all, you check where it is becoming negative. Whenever the term becoming negative, please neglect those terms. Okay, so I'll put x is equal to 1. It will not become negative, so I'll have to keep it. And if I put 1 here as well, it will simply become 0, so don't bother about it. But when I put 1 here, it will become negative, so I'll have to drop this term. And if I put 1 here, it will also not trouble me. Okay, so I'll use these 3 terms and I'll have to drop this term. Okay, so now you can put the value of x. So now you can put the value of x, guys. So as you can see there, 62.5 into 1 ka cube, this will already become 0, and minus 637.5 into x ki value 1 rakh di, and definitely you will have to divide by ei. Why ei? Because it is ei into y. So once I put the value of ei value was already given in the question itself, that is 4800 into 10 ki power 3. You will get deflection also. You will get deflection also, that is minus 0.1198. Now guys, what about this negative sign in case of deflection? Like as I already told you that in case of slope, negative sign signifies that it is in clockwise sense. Now what does it signify in case of deflection? It is simply showing us that the beam will go downside. Whenever you will have deflection occurring in downward direction, it will be negative, and whenever you will have deflection in upside direction, it will be positive simply. Okay, so hope you guys have understood the problem. Okay guys, so now I'm going to take one more problem. As you can see this below, the problem is stating us that it is again a simply supported beam with a moment acting at a distance of 3 meters from the left support and 1 meter from the right support, right? So first of all, what I said in the earlier question, I said now that first of all you have to calculate the reactions. Okay, reaction calculate karenge pehle. Hope you already know how to calculate the reactions. If you don't know, then please follow the above steps that I use to calculate the reaction forces. When you guys are done with your calculations of reaction, you will get 450 Newton at A support in downward direction, and at B support it will be in upward direction, but again it is 450 Newton. Okay, please check your answer if you are getting the same values. Okay, now I'll straight away going to use the equation of ei y double dash is equals to m. What is this m, guys? This is the this is the bending moment. I'll have to calculate the bending moment in the last section or in the last region of the beam. Guys, you can clearly see that there I have two regions. Region number 1 AC region, and another one is CB region. So of course I'm not going to calculate the bending moment in AC region. I'll have to calculate in BC region. So of course I am going to calculate in BC region. So I have cut down a section at distance x from the left support, and again I am going to repeat the same steps as I did in earlier question, right? So you can see 450 into x. What is the nature of the bending moment it is producing? Of course it is producing hogging. Of course it is producing hogging. 450 into x, 450 into x with negative sign, because it is giving us hogging bending moment. Now what about this 1800? What about this 1800? It will give us you can clearly see, guys, it is definitely sagging bending moment. So with plus sign I'm going to write 1800. Now what is this? What is this? Now I'm not going to explain it that much, because I have already explained during the rules of Macaulay's method. So please go through with that video if you are not understanding why I have written x minus 3 into 0, right? So please make sure to go through that video. Okay, x minus 3 to power 0. Now what I'll going to do is I'll simply integrate the whole equation. Once I integrate ei y dash, I'll get ei y dash minus 450 x square by 2 plus 1800 x minus 3. For earlier it was of 0 power, now it will become x minus 3 of power 1, plus this is the integration constant. Now I'm going to again integrate this whole equation, that is ei y minus 450 x cube by 6 plus 1800 x minus 3 square by 2 plus ax plus another integration constant b. Guys, I know few of you might got confused why I integrate the term in this manner. Why not in 8x square by 2 minus 3x? Because again, please go through the rules of Macaulay's method. This is another specialty of the Macaulay's method which makes it very much popular. Okay, so definitely I'll have to integrate it like that, not by the conventional method that we used to do, x square by 2 minus 3. If you do so, it will become wrong. Okay, and you will not be getting any correct solution. Okay, great. So guys, now I'll have to I'm again going to use that boundary conditions, like if you put x is equals to 0, you will get deflection 0 at support A. Similarly, if you put x is equals to 4, again you will get deflection 0 at support B. So I'll be going to use these two boundary condition to know the values of two unknown, to know two unknown values. And first I'll use x equal to 0, y equal to 0. It will give me b equal to 0. Okay, I'll be using this equation. Guys, please, while using x equal to 0, please neglect this term. Why to neglect this term? Because 0 minus 3 will become negative, so you will have to neglect the term. Okay, then once you neglect this term, you will get b as 0. Now another boundary condition I'm going to use is at x is equals to 4, deflection will become 0 again. Why 0? Because this is again a support end, and support पर कभी भी कोई deflection नहीं हो सकता. Please mind it. Great. So again I'm going to use this equation and put the value x equal to 4. Please check first of all that whether you are getting any negative term or not. If you are getting any negative term, please neglect it. So if you put 4 here, it will not going to give you any pain, and if you put 4 here, again this will again a fine term, and this will also. So if you put 4, you will get the value of a as 975. Now what I'm going to do is I'll be going to substitute the values of a and b in above these two equations to get the value of deflection, and to get the value of slope. Okay guys, so here they are: ei y dash minus 225 x square plus 1800 x minus 3. I did nothing. I am just simply writing down the equation and I am substituting the values of unknown. Okay, a की value we have already calculated, that is 975, and similarly I am going to substitute the values of a and b in this equation. ei y minus 75 x cube plus 900 x minus 3 square, and a is 975 x and b तो पहले से ही 0 हो चुका था, so it will become 0. Okay guys, now these are two general equation of getting slope and deflection at any point in this beam. Okay guys, at any point in this beam. Hope you like this video. Please go and study hard. Okay, मिलते हैं जल्दी नई वीडियो में एक नए कॉन्सेप्ट के साथ. Till then, take care, bye bye.